Good morning, good afternoon, everyone, to various parts of people who are joining from different time zones. Let me know if you can see my screen.
Yes, perfect.
Okay, so that's the content, and not to divulge too much into the concerns side, move on. So something about Cyan Renewables. Cyan Renewables was formed about 3 years ago, backed by some infrastructure funds. We are primarily providing offshore vessels in oil and gas and renewable sector, and also in the subsea side. Headquartered in Singapore, we currently operate about 35 vessels, either in offshore wind industry or in oil and gas, and transitioning towards the renewable industry. From key capability perspective of Cyan Renewables, we support vessels, we provide vessels, we have in-house ROV and light subsea construction work capabilities, geophysical and geotechnical surveys, scour protections, and turnkey transportation projects. We do have operational hubs in Australia, Singapore, Taiwan, Korea, UK, Denmark, and Malaysia. That's something about Cyan Renewables. Moving over to the challenge statement and why we have chosen this statement. There is a big gap in the supply chain when it comes to the vessels, especially for offshore renewable sector. There are approximately 4 to 5,000 offshore support vessels operating in the world. While the supply chain is quite slow, building a new vessel with latest technologies may take about good 2 to 3 years before they see the light of operations. And then eventually, what do we do with the current tonnage? And as we operate vessels which are just nearing their midlife period, about 13 to 14 years of age, we do have another 13 to 14 years of operational capabilities of these vessels, and how do we lower our carbon emissions? And from that perspective, this is the challenge, that a particular vessel can operate in dynamic position, and generally it operates about 60 to 70% of the time, where the redundancy requirements are pretty high, in way that in case if there is a single point failure, the vessel should be able to maintain position and exit the location safely. The only way we can reduce the emissions is if we reduce our running generators or running engines on board the vessels. Now, when we reduce the running generators or engines on board the vessel, we are reducing the redundancy concept of the vessel. So our technical requirement for the solution is that it becomes a decision support tool for the navigators on board the vessel. When I'm working in lower or reduced redundant mode, the model is predictive in nature enough that it assists the navigators with an alarm or a warning to say that the vessel may not be able to maintain position if a failure were to happen at that very instance. This would help the navigators to trigger an increase in generator operations, which eventually helps us to reduce the carbon emissions. So what is a dynamic position? It generally has these key components, key components in terms of position reference, motion sensors, environmental sensors, computers, power system, thrusters, operator station. And redundant mode is that there is redundancy not just in power or the thrust systems, but it also has redundancy in reference sensors control systems as well. This is what a typically existing DP2 vessel looks like. It will have 4 generators, 2 redundant group. One is on the left side, which is port side, and one is on the green side, which is starboard side redundant group. There is enough redundancy in power generation, in thrusters, in cooling systems, various components of the vessel. So what the ask is that in case if we are operating the vessel in lesser number of generators on each side, a typical DP would require that all 4 generators are running at any given time, so that in case if there is a failure on one of the redundant group, the second redundant group should take over the control to maintain the station. Uh, with that, a lot of time what happens is we are running all 4 generators, but the demand from the thrusters as well as other ancillary equipments is not enough or not congruent to the power available on board or power generators which are operating. So we want to look for a solution with which we'll be able to reduce the running generators. So the technical requirement is determine the environmental and operational parameters for safe reduced engine operations in DP, maintain the redundancy under optimized conditions, adaptable to various engine generator thruster configurations, and it should be retrofittable, no replacements of equipment on board. It may require some sensors. We are okay looking at those addition of hardware sensors as well. And the data gathering should be analytical in nature, with which we'll be able to analyze how we are operating the vessel. The performance requirements is that with that decision support tool, it should be able to demonstrate that we are still operating in the safe performance in a predictive in nature. Proof of concept and the pilot side are mentioned here. I would rather take some questions than going into the proof of concept side. This would be shared with all of the participants. Just a second. So this is how, from a pictorial representation, this is how it will look like, that if we have 2 generators running with all the thrusters running, it is predictive in nature enough that it is taking input from all the sensors on board the vessel, including the machinery. And then it is analyzing and predicting in nature that in case now suddenly there were a failure on the generator or a switchboard, then it will trigger an alarm or warning to the operator to start other generators so that there is enough power availability at any given time. Or in case if in case if it is unable to maintain, then it is giving an alarm in that nature. That's it from my side. If you have any questions, I'm happy to take it.
You've got any questions on Captain Gareth? Type it in. Okay, right. I think we have a question. It's quite a long one. Captain Gareth, could you click on the chat box in order to read it as well? I'll read this as well. We have
It's okay. I'll read it. Yeah.
No, I do have to read it for the benefit of the recording. We have a proven retrofit system that works very effectively to reduce fuel consumption from 2 to 15%, and exhaust emission drastically. And we have tested on large DG sets successfully. We have our own IoT, etc. Therefore, very effective with all ancillary engines in a vessel, and also open main engines, even though we have not tested on the vessel yet. We have some marine operators also in discussion. Only challenge is, as a startup, we cannot afford the type approvals mandated by IMO. will this opportunity help us to validate on your vessel and also get support on type approvals? And does your requirement is getting partly met by our solution?
So,
multi-part question.
yeah. So, hi, Alok. I'll take bit by bit on this one. As far as the solution goes, it has to integrate dynamic positioning. That is the major part of it. From an offshore vessel perspective, we generally have 4 engines. We could even have 2 main engines. We could even have a diesel electric system or 4 generators driving propulsion. When we are in non-DP mode, which is generally 30 to 40%, I can reduce because there is no redundancy concept, and from SOLAS or IMO requirements we meet with a single generator, the consumptions can be reduced substantially. Our main concern is that while we are on DP, we have to operate those 4 engines, but then we want to get a solution which helps us to predict environmental conditions and vessel motion in a manner that in case if the failure happens, we'll be able to reduce or will be able to recover from that failure preemptively before the failure happens. So I understand that you have a system, but that is from the chat group, what I understand is it is for existing conventional vessels. What we are looking at is a specific mode of operation. As far as the IMO concern, what I can advise is that DNV specifically, which or can you hear, Derek?
Yeah, you broke up for a little bit. Can you repeat the last question ending at IMO?
Yeah. So what happens is from DNV does a lot of proof of concept approvals. So basically, they will go through your documentation and see if you have a basis of a proof of concept, which means then you can approach to any of the owners, vessel owners, and they may be able to implement those technology onto the vessel, even though you may not have IMO approval or type approval from that perspective. So DNV does that, and they are at the forefront of this aspect from classification societies.
All right, thank you. Any more questions for Captain Garaf? Next question, what exactly are you using this option for? Why is it important to stay in a fixed position?
So offshore vessels from the first presentation, you must have seen that the turbines need to be installed in the sea. You would need vessels to do those kind of operations, standing or really fixed at a position to either install those turbines or do marine installation work, or they could be used to do supply runs, which means we could be sending people to those turbines. And how do we transfer those people is when the vessel is fixed in reference to those turbines, then we will connect our gangways, which are again motion compensated gangways, and the people will transfer over from the ships to those turbines. So DP needs dynamic position is the only way we maintain the station keeping, which means it is fixed at sea in reference to a particular position. And there may be any other kind of works, marine works, construction to supply to people transfer, subsea construction work. We could be drilling as well. And for all those works, you need a dynamic positioning.
Okay, well, thank you. I think we do have to move on because we're slightly over budget in terms of time. So if anybody was got any further questions, email us and we'll try to get those questions answered. But